let's look at distance formula real quick. Starts off, and I would like you please to write the distance formula each and every time you encounter it, so that way it gets into your head. I am going to write it, but I'm going to change the colors on everything to match the colors of my labeling up above. Once again, it doesn't matter which point you select to be X1, Y1, just make your selection and make sure that the other point then becomes X2, Y2. Okay, so there's my formula. Now that I have my formula written and I've got it color coded, I can see what numbers go where. I'm going to go ahead and do the substitution. And once again, I'm color coordinating the substitution in hopes that it makes it easier for your eyes to track where we're going with this. Okay, so far so good. I see a double negative there. I'm going to get rid of that double negative by turning the two next to each other into positives, but just those two. Don't go changing sign happy with everything. Okay, this is a negative 17. Took me a bit to think that number through. Negative 4 plus 10 is a positive 6. I heard someone say in the back. Thank you for rescuing me from those numbers. I'm going to grab my favorite calculator app because I have no idea what 17 times 17 is. I really don't. Okay, so let me clear that number. Whoops, come back here. 17 times 17. Calculator app says it's 289. And I can do 6 times 6, that's 36. Now, 289 plus 36, calculator app tells me, is 325. Now, at this point, a lot of you probably would have stuck this in your calculator, gotten a decimal, and then if it was multiple choice, and if your multiple choice answers look like this, you would have put that in your calculator and gotten a decimal and kept going until your decimals matched up. But I want to show you how you get this number as is and where it's coming from. To get that answer, we're going to take 325 and do a process called prime factorization. This is when we list out all the numbers that you need to multiply together to give me 325, but do it in such a way where each and every single one of those numbers can't be divided by anything else. I'm going to start by trying to find two factors of 325. Now, looking at the last number is a 5, which tells me automatically it's divisible by 5, and I know 5 is a prime number. So I'm going to start with that and then see what happens. So once I divide 325 by 5, I end up with 65, which again is divisible by 5 because it ends in 5. Okay, 13 doesn't end in 5, and I'm going to think, is 13 divisible by anything else? It's not an even number, so it's not divisible by 2. I can't divide it by 3. Yeah, I can't think of any others. It has to be a prime number, okay? So I'm done. Here are my prime factors of 325. And this means that I can trade in the number 325 for the numbers 5 times 5 times 13. And I hope that by right now you're going, why would you do this? It was a nice, beautiful number, 325. Okay, it was big, but... And now you're telling me that it's the square root of number times a number times a number. And this seems really weird, yeah? Yeah. But it's because when you have radicals that have a whole bunch of multiplications in them, you can Fruit Ninja into the radicals wherever there is a multiplication symbol and break it into two completely different radicals separated by a multiplication. The property is called the product property of radicals. They'll show that to you in Algebra 2. But you can do that, but only when there's multiplications. If you've got some additions in there, we can't do it. Okay, but all multiplications, we can totally fruit ninja. This means that this radical over here has the 5 times the 5, and this radical here has the 13. They have been separated, which still doesn't look helpful until you think about what radical means in math. What does the square root ask for? Let me ask you this. What's the square root of 4? Why? Because 2 times 2 is 4. What's the square root of 16? 8 or 4? She said the square root of 4 is 2 because 2 times 2 is 4. So I asked what's the square root of 16, and we're having 4 and 8 as answers.
But it would be 4 times 4.
4 times 4 is 16. Yeah, you're doing 8 plus 8. Square roots then are asking what number do you multiply to itself to give me the number inside of the radical. Square root has a square power. That power is 2. So square roots are asking what number is multiplying to itself 2 times inside of me. Inside of this, what number is being multiplied to itself twice? 5. And so its evaluation is just 5 and nothing else. Not square root of 5. Just 5. Because that's the answer to the question. What number is multiplying to itself 2 times? 5. And this one, solito, poor thing. We can't do anything else about it, pobrecito, so we're just going to leave him just like that. And it gives us, cover the response that we're looking for. And I had a question earlier from here. Miss, couldn't you multiply those together in there? Sure. Yeah, you can totally do that. What's the square root of 25? Sure. Totally gets you to the same place. But I really want to stress this thought process of which number is multiplying to itself 2 times in this square root? 5. Because in Algebra 2, you're going to have to do something like, what's the cube root? Cube for 3. Which number is being multiplied to itself 3 times? And then you're going to be asked to find the 4th root. So which number is being multiplied to itself 4 times? And you might be asked something weird, especially if you had me as an Algebra 2 teacher, like, what's the 11th root? Which basically means which number is multiplying to itself 11 times. So I really want to drill home this idea of which number is multiplying to itself a certain number of times. Does the simplification of radicals like this make a little more sense than they did before? Give me thumbs up if it makes a little more sense. Give me thumbs down if it just confused you even more. Vote now.